So, Ebola, or as it used to be called, Ebola hemorrhagic fever, is a doozy of a disease, man. It is one of the most efficient killers out there to date. And so it has rightfully earned a lot of fear and respect from communities when they hear about it, okay? I've been doing a lot of research on it, but there's this really quick video I want you to see that breaks down how Ebola affects your body and what it does. So catch this and I'll catch you on the flip, okay?
Blood clots begin to form. Internal organs begin to fail. And in a matter of days, the body hemorrhages and dies. Terrors, all caused by a nightmare, come to life. Ebola is a rare but extremely dangerous disease. It's classified as one of the most lethal diseases on the planet, with a fatality rate of up to 90%. Ebola is caused by 6 species of virus, with 4 known to cause sickness in humans, and each is named after the locations of their outbreaks. The first known species was Zaire Ebola virus, discovered in 1976 near Zaire's Ebola River, a river fated to become the namesake of all Ebola viruses. Like all viruses, Ebola viruses infect and feed off of their hosts, starting on a microscopic level. The viruses, which are string-like structures, contain genetic information in the form of ribonucleic acid, or RNA. Encasing the RNA are layers of proteins. The proteins on the outermost layer are highly versatile, capable of changing shape and binding to different types of cells within a host. When binding occurs, the Ebola virus fuses with a host cell, allowing the virus's RNA to infiltrate the cell and replicate the virus from within. This infection quickly spreads to countless cells throughout the body, resulting in some of the most terrifying symptoms known to man.
So, usually, dendritic cells would activate an army of antivirus cells, support cells, and antibody factories that would, together with the guard cells, wipe out the infection in a matter of days. But when Ebola strikes, it directly attacks the immune system. Some of the first cells it takes over are the dendritic cells, the brains of the immune system. The Ebola virus enters a dendritic cell by binding onto receptors for cell transport. Once it's inside, it dissolves its outer hull and releases its genetic material, nuclear proteins, and enzymes. In a nutshell, it takes over the cell, disables the cell's protective mechanisms, and reprograms it. The cell now becomes a virus production machine and uses its resources to build Ebola viruses. Once the cell is saturated, it dissolves the cell membrane and millions of viruses are released into the tissue. The virus not only prevents the dendritic cell from activating the specialized antivirus forces, it manipulates it into sending signal proteins that trick the specialized cells into ending their own lives prematurely. So the immune system is seriously disrupted and unable to react, while the virus rapidly multiplies. We're talking billions. There are cells that should deal with infected cells, the natural killer cells. But they also get infected and just die before they can prevent the disease from spreading. At the same time, Ebola infects the guard cells of the body, macrophages and monocytes. Not only managing to circumvent their defenses, it also manipulates them to signal to the cells that make up the blood vessels, telling them to release fluids into the body. Usually this makes sense, but in this case, it just causes mayhem. All over the body, neutrophils are activated, awoken by the virus and the macrophages' signals. They're not very effective against viruses and should not be involved in this fight and begin to do lots of stuff they shouldn't do. The neutrophils signal the blood vessels to release more fluid, causing internal bleeding. Another area of the body Ebola attacks is the liver. The virus finds it very easy to enter the liver and it quickly starts killing loads of liver cells and causing organ failure and more internal bleeding. And all of those things are going on at the same time. As the virus spreads, it's like nukes exploding everywhere.
Within 8 to 10 days, those infected by the Ebola virus may experience symptoms drastically ranging in severity. From fevers to diarrhea and vomiting, to internal and external bleeding, often from the eyes. While outbreaks have been caused by multiple species of Ebola virus, the strain with the highest fatality rate was the first to be discovered, Zaire Ebola virus. In 2014, it caused the most severe outbreak in history, sweeping through Western Africa and resulting in over 11,000 deaths, more than all earlier Ebola outbreaks put together. At this point, no cure for Ebola exists. Plus, the communities most likely to be affected do not have sufficient access to healthcare. In the meantime, international efforts are being made to develop and test vaccines that could potentially stop the disease once and for all.
Scary, right? The fact that it's attacking your body's ability to fight back against it is one of the reasons why Ebola is so deadly, right? Ebola has a mortality rate of around 50%, meaning that if you get it, you have a 1 in 2 chance of not making it out, right? And that varies, right, depending on access to resources. So it could be as low as 25%, but it could also be as high as 90%. It's a very efficient killer, right? And I think part of the reason why it's so scary is because of the way that it kills you. As you're dying, you kind of crack and bleed out, right? As your body's getting those signals to release fluid, your eyes start to fill with blood, right? And you get these red eyes, you get sores all over your body that are pussing and bleeding, right? It is a very painful, horrible way to die. But also, since you're emitting all of these fluids from your body, you're also making it so that other people can get the disease, right? Now, one of the things that's true about it that's very different from COVID-19 is, since it requires people to actually have physical contact with one of the major body fluids, it makes it less transmittable. You have a lot less chance of getting it than you would from COVID-19, where if someone coughs on a table, you might get it like 6 hours later, right? You really need to have a lot more direct contact with people, which is one of the reasons why Ebola didn't spread as fast. But another reason is because we have a really clear way of tracking it. Now, watch this next video, and I have a question on the flip side before you get to your assignment.
At CDC, our mission is to prevent, detect, and stop disease outbreaks wherever they occur. And that's why CDC disease detectives are hard at work 24/7 in West Africa.
Hi, Greg here. I'm with Ishmael, and we're going out with our UN colleagues to train contact tracers.
In the fight against Ebola, one of the most important tools we have to prevent spread is contact tracing.
Odi? Habari, Mami?
In fact, it is the key to stopping the outbreak and saving lives.
She wanted to know how we are going on. Anybody who has been sick, anybody who has been in hospital.
Contact tracing means finding everyone who comes in direct contact with a sick Ebola patient. We ask the Ebola patient or their family who the patient had contact with since they started their symptoms. These contacts are then found and watched for symptoms of sickness for 21 days to see if they become ill. If a contact begins to show symptoms of Ebola, he is immediately isolated, tested, and provided care, and the cycle starts again. All of the new patient's contacts must be found and watched for symptoms of sickness for 21 days to see if they become ill. The process is repeated until there are no new patients.
That's how we're going to stop the transmission chain of Ebola.
Contact tracing identifies new Ebola cases quickly, so they can be isolated as soon as they show symptoms, preventing spread to others. In the event someone with Ebola travels to another country, we would use contact tracing there as well. The truth is, even one missed contact can keep the outbreak going. But by carefully tracing all contacts and isolating new cases as soon as they develop symptoms, we can prevent further spread. By working together, CDC and its partners will stop the outbreak and save lives from this devastating disease.
So here's my question. If community tracking was so effective for Ebola, why didn't we do that from the outset with COVID-19? Well, some countries did, right? If you're looking at the previous lessons, we talked about how other countries dealt with their pandemics of COVID-19. Like South Korea and Germany did a lot of testing, and South Korea did a lot of this contact tracing, right? So think about, I guess a better question is, why didn't we do it so much here in America? All right, so answer the questions in the assignment I've got, and good luck.